want to talk to or like care about?
Okay, you guys. So to finish these last ones, we talked about simple harmonic motion yesterday, so we kind of went over that. So what we need to do today, we're just going to write our equations. So remember, these are sine or cosine equations, and we need to figure out which one we need to use. And then we need to use our amplitude, our period, and figure out all of our different stuff to put in our equation. Okay, so if I read through this, the first thing to help me know if I'm going to use sine or cosine, if it says the spring is at equilibrium, so it's at rest, so our distance, because it's just right in the middle, it's not stretched or compressed at all, so our distance is 0 when our time is 0. So that means I'm starting on my origin. Okay, so if I'm starting on my origin, am I using sine or am I using cosine? Sine, yep. So I'm going to have, so since it's d and t for distance and time, so we have our distance is equal to, what's my amplitude? What does it say up there?
10.
10, yep, so I'd write 10. We decided it's sine. Now I need to figure out what my b value is. So it tells me that my period is 4 seconds. So if my period is 4, I know that I can set that 4 equal to 2 pi over b to figure out my b value that I'm going to need to write in my equation. Okay, so if I do this, I can just cross multiply. And then, Blake, what would I have? How would I do this?
You have to do 2 pi divided by 4.
Yeah.
You get 1 half.
Yeah, so my b value is going to be pi over 2.
Okay.
Yep, 1/2 pi, so pi over 2. Okay, so our period is, it told us our period was 4 seconds, so I need to go ahead and put pi over 2 in here. Okay, because remember, your period and your b value are not the same thing, so you don't just plug the 4 right into your equation. Okay, so we have pi over 2. We're not shifted left or right, we're not going to have that with these. So then I would just have pi over 2, and then I need actually t because it's time. And then that would be our equation, okay? Because we're not moved up or down or left or right, so really we're just dealing with period, so we have to solve for the b value, and then we use the amplitude. Okay, so there's our equation. And then the last thing, it says we need to figure out our frequency. Do you guys remember how we figure out frequency from that equation yesterday? Did anyone write it down?
B over 20?
Or
Or 2 pi?
Yeah, b over 2 pi. Yep, because it's literally just our period flipped. Okay, because the frequency is b over 2 pi. So it's just like we're just taking the opposite of our period. So if we plug this in, our b value was pi over 2 over 2 pi over 1. I can go ahead and multiply by my reciprocal, so I'd multiply by 1 over 2 pi. And then I'd have pi over 4 pi, which that's going to give me 1 over 4. Okay, so you don't have to do it like that. You could literally just flip your period. So if your period is 4 over 1, you flip that, so your frequency is going to be 1/4. Okay, so period and frequency work together like that. Okay? Are we okay? So it's just like sine and cosine equations. It's just like putting a little bit of a real life spin on them. Okay, let's do another one just to practice.
Do you guys think they're going to be frozen strawberries with the hot dogs?
No, we just had them this week already.
All right, guys,
Yeah,
so
me
this
too.
one, instead of us writing the equation, I gave you the equation, and we're gonna answer all the questions, okay? So, what?
Not related, sorry.
Okay, so we have d, so our distance of our spring or our ball or whatever is equal to 6 times the cosine of 3 pi over 4, and then times t. So I need to go ahead and figure out my max displacement first of all. So you know that your max displacement is your amplitude because it's how high up or how far down that ball on that spring can go. So what do we think our max displacement is going to be, Madison?
6.
Yeah, so our max displacement is 6 because it's the same thing as the amplitude. question, it asks me my frequency. So Shannon, what'd you say for that? 1/6. How'd you get that? The period flipped. Okay, so this is my amplitude.
So that's 4 pi over 3.
And this is my B value, right? So we can't just flip this one. So remember I said frequency is B over 2 pi. So if we don't actually know what our period is, we can't flip it because from the equation, I don't know what my period is. But we do know what my B value is, so I can plug it in the B over 2 pi. So if I do that, I'd have 3 pi over 4 over 2 pi over 1. And then Shannon, what do you think I do?
3 pi over 2, 3 pi over 8 pi, so it's just 3
Yeah, because if I multiply by my reciprocal, I'd have 3 pi over 8 pi. Pi's can cancel, so it's just going to be 3/8. Yep. Okay. So frequency and period go together. So if you don't have your period, you have to either figure out your period first to flip it, or figure out your frequency just from the equation. Okay. Then the next one, it says the value of D. So where our spring is, the distance of our spring after 4 seconds, when our time is equal to 4 seconds. How do you guys think I'd figure that out?
Did you just put 4 into T?
Yeah, I'm just gonna put 4 in for T. Yep, so if I just put 4 in for T, I can solve this, and I'm gonna get my distance. Okay, so I'd have D equals 6 cosine of 3 pi over 4 times 4. If you're just gonna type all this in, make sure you're in radians mode, okay? Because we're using pi's. So I would grab your calculator if you don't have it, or we could figure it out. If we think 3 pi over 4 times 4, what does that give me? What do you think, Madison?
Oh,
What are you doing in there? I'm number 9, Carter.
What'd you get?
She has 0.9.
Are you in radians?
Thank you so
Yeah.
much.
Wait, don't you take 6 times the cosine of 4 times 4, right?
So this is the angle. This would need to be multiplied together first. Okay?
So, okay.
So if you're typing this in, guys, it's 3 pi over 4 times 4. Like, this is all my angle. So you know that 3 pi over 4 times 4 would just be 3 pi, because those 4's would cancel each other out. So we'd have the cosine of 3 pi, okay? And then that times 6. And if we think about on our unit circle, 3 pi, here's 2 pi, 3 pi would be right here. My cosine there is gonna be what?
Negative.
Yeah, -1, right?
That's what Alyssa she was at.
So we have 6 times -1, which is -6. And you should get that when you type it in, but if you were just to type all of this in, you need to put like an extra set of parentheses around this, so that it doesn't take the cosine of this and then multiply it by that, because it's the cosine of this whole angle. Okay? So either throw an extra set of parentheses, or just kind of think about it.
How do you get the negative? You have to know that, like, your calculator doesn't do that, right?
It should.
You gotta show me how to do that.
Yeah, let's see. You're in degrees.
That's on me, sorry about that.
There you go. Okay? All right. Then the last part, it says the least positive value of our time for which our distance is 0. So if we think we have this cosine curve, so I'm starting up at an amplitude of 6, starts up, I'm gonna go up and down and up and down. I'm trying to figure out when my spring is gonna be at equilibrium. So it's not stretched out, it's not compressed. So I wanna figure out the first time in which my spring is at equilibrium when my distance is 0. So if distance is my y, so when my y is 0. So I want to figure out the first time, because it says the least positive, so I'm on the positive side, but I want the first one, because there's going to be lots of times that spring is at equilibrium, but I'm just trying to figure out the first one. Okay, so then the way that we do this, it just depends on if we have sine or cosine, but it says to find this value, we either can graph it. We could literally go through all the steps. We know how to graph cosine graphs. Or we can just set our bx minus c equal to where our first x-intercept of our non-shifted graph would be, which is gonna be at pi over 2. Okay, so if you set this, because usually we were looking for left and right endpoints and we were setting it equal to 0 and 2 pi. Well, this isn't an endpoint, because usually my graph starts up right here, so this is the endpoint. So I'm not looking for that point, I'm looking for where my cosine graph typically hits my x-axis, which is at pi over 2. So in order to solve something like this, we just need to take this bx minus c and set it equal to pi over 2, okay? And you will have some of these in your homework, so I would write that little equation down.
What little equation that?
Just like set it equal to pi over 2. And this is for cosine. When we do sine on that on our last example, it'll be different, okay? So to find your least positive value, so basically to find your first x-intercept, you need to set your bx minus c equal to pi over 2. So what is our bx minus c, Jasmine?
3 pi over 4.
Yeah, and I don't have anything else, so I just have the 3 pi over 4 t, and then I can set that equal to pi over 2, and I need to solve it for t, and that's gonna give me this time right here when I'm gonna go ahead and cross over my x-axis. So then Alyssa, go ahead and help me, how would I solve it?
You would divide by 3 pi.
Okay,
Is out.
So then you multiply by
Is he here this morning?
Yeah.
Oh, here he comes.
over 2 times
okay,
then you get 4 over 6, so I guess plus 2 over 1.
yeah, 2 over 3. Yep, so you guys, so Alyssa helped us, so we just set the 3 pi over 4 equal to our pi over 2. If I divide by 3 pi over 4, I can go ahead and multiply by my reciprocal. So I have 4 pi over 6 pi. All that simplifies out. So this first x-intercept is gonna be at 2/3. So after 2/3 of a second or a minute or whatever we're counting by. So after 2/3 of a second, that spring is gonna be just at its rest position. So it goes from being like up here on the spring, and then it's gonna be rested, and then it'll go like stretched out and come back and rest and go up and down and up and down. Okay, how do you guys feel?
Dandy.
Dandy, all right, I have one last one, just because it's with sine so that we can see both, okay? So this one, we have the equation d is equal to 1/16 sine of 120 pi t. Okay, so if we answer our questions, we have our max displacement. Blake, what do you think that'll be?
1/16.
Yeah, 1/16. So this one, it doesn't go very high or like very high or low at all. So it's just 1/16. So remember, that's the same as the amplitude. Then I need to figure out my frequency. So we know the frequency is opposite of the period, but I don't have a period, I just have a b value. So I can use my frequency equation of b over 2 pi. And then, Brady, what's my b value?
Sheesh, I can't see it. It looks like 120.
Okay, 120 pi, right?
Yeah.
Yeah, 120 pi. So if I take 120 pi divided by 2 pi, Brady, what does that give me?
60.
Yeah, 60. Yep, so my frequency is gonna be 60. So this wavelength occurs, like the frequency is really high, so it's probably like a really high pitched wave, like, doesn't go up or down a lot, it just has a lot of times, it's really frequent, okay? And then the last one, it says the least positive value of t for which our d equals 0. So we're trying to find the first time that it's gonna cross my x-axis. So if I'm graphing sine, so we're graphing sine, so we start at our origin, and then I'm gonna go up to 1/16, back down, up and down. So up to 1/16, down to negative 1/16. I don't count the first one where I start, that doesn't count. So I wanna figure out the next value, so how much time is gonna pass before I'm back at my equilibrium. So with sine, we're gonna set our bx minus c equal to pi, okay? So, Madison, what's my bx minus c? Yeah, 120 pi t. And then I'd set that equal to, okay, and then if you solve it for me? Okay. So I get, so if we take pi divided by 120 pi, yeah, 1 over 120 when I simplify that, because the pi's will cancel each other out. Yep, so after 1/120th of a minute or second or whatever we're counting by. So, like I said, the frequency was really fast, so it makes sense that it's just a short amount of time before it's back at equilibrium. Okay, so the higher your frequency is, like it's gonna, like the wave is just like a lot more condensed. It's just a lot quicker, okay? All right, guys, that's everything